rule is what permits us to differentiate compositions of functions. And the analogy that's usually used is the two spinning gears. Say that you have one gear spinning at 2 revolutions per minute. We have a smaller gear here that turns 3 revolutions per revolution of this. So this goes around twice, this goes around 6 times. How did you get that rate? You multiply them, all right? It's the rate of change of this with respect to time times the rate of change of this with respect to this. Symbolically, you get a function here, differentiate the composition. The way it goes is, it's going to be f prime of g of x times g prime of x. The derivative of the outer with respect to the inner times the derivative of the inner. For example, this is usually expressed in terms of if you have f of u of x. Sometimes it's written as df dx equals the derivative of f with respect to u multiplied by the derivative of u with respect to x. Chain rule. Examples of this, it basically comes down to identifying what's the inside function and what's the outside function. With this here, you have an outside and the inside. The outside is cosine, whose derivative is minus sine, keep the inside, x squared plus 1, multiply that by the derivative of the inside, 2x. And that's it. If you can identify the inside and outside, it's all over. Got another one here. This thing. What's the outside and what's the inside? The outside is the radical. It goes over the entire thing. So the derivative of the square root of something is 1 over 2 square roots of the whole thing and x. And you have to multiply that by the derivative of the inside function. So that's the derivative of x squared is 2x plus the derivative of tan, secant squared. Just the product, like so. You can have the chain rule in conjunction with the other rules. The outside function is cosine here, but for the inside function, it requires the product rule. It can get kind of nasty, but we can handle it. The derivative of cosine is minus sine of x sine x. And you have to multiply that by the derivative of the inside function, which requires the product rule. So f prime g sine x plus g prime f, the x cosine x. Close that off, and now you have the chain of two things, right? Outside times inside, and that's it. Then you get more complicated, though. You can do multiple chain rules. There are 3 functions here. Now there's an outermost, and there are 2 inside functions. All right, the outermost function here is the squaring function. And the next function in is the sine, and then the next function in is the 5. So what you're going to do is, the derivative of the square is going to be 2 times, keep the inside. Alright, now that takes care of this square. So you're left with what's on the inside. The next function in is sine, whose derivative is times cosine of 5x. And then the next function in is the 5x, whose derivative is just 5. Last example, you can also do this with unspecified functions. It's actually easier. We have a chain of order 3 here. We have the cosine. The next function in is f, and the next function in is the x squared minus 1. So to carry this out, the outermost function is cosine, whose derivative is minus sine of f of x squared minus 1. Multiply that by, now we do this one. The derivative of f, we just write as f prime. F prime of x squared minus 1. And then we just multiply that by the derivative of the inside, 2x. There were 3 functions, cosine f in the inside, so you have 3 links in the chain, so to speak.